Hello and welcome back. This is Paolo, your host, and this is another episode of Conversations in Artificial Intelligence. Today we have a very interesting episode, and we're going to look at ways that artificial intelligence is going to be automated. So ways that you start with an idea, you're a manager of a company, you start with an idea, and you want to rapidly create an artificial intelligence product that it gets deployed. So today, things require quite a bit of time. You see as a consumer of artificial intelligence the benefits, but you don't know how much work goes in the back of all this. And today we're going to talk about how all of this is going to make easier in the future. And with us today, there is Pedro Alves, who is the CEO and founder of Ople.ai, a very interesting startup here in Silicon Valley. Hello, Pedro. How are you today?
I'm great. And yourself?
I am very good. Thank you for being here.
Yeah, my pleasure.
So, Pedro, you have an interesting background. You've been a scientist in academia and moved to Silicon Valley, where you've been part of several startups. I wanted to start, getting to know a little bit yourself and asking you typical things, like when you moved from academia to the startup world, what does change in your work? What did you learn? And how is the job of being a scientist in academia different than being a scientist in a startup in Silicon Valley?
Sure. So I had spent about 12 years in academia. Most of my work was in AI machine learning, using data from different fields. So I was actually in the field of genomics, but that to me was just a good source of data. My passion was always machine learning AI, and I just thought genomics is a good place to practice that field. When I moved into industry, I actually first moved into a large company before coming to Silicon Valley and doing the whole startup thing. So I experienced, the typical big company type of experience. I had worked and advised and consulted for other large companies, and then came to the Valley and started working with much smaller companies. So I think, I learned a lot about the differences between academia and industry, like you asked, but also between types of industries.
At a certain point, you came to Silicon Valley, and I know that you've been in a number of startups, including Sentient, that is considered one of the startups that does more advanced work in machine learning. They developed a number of technologies and so on. So how did you decide to start the company, and what type of need did you identify, and how the idea of starting a company came about?
So the idea came from experiencing data science in industry, interviewing people and seeing what the frustrations were with people managing teams, with people running teams, but also people doing the work, right? And what I saw was that on one hand, you have AI being this fantastic potential and something that can change industries. And on the other hand, you have the reality, which is more than 90% of the time, the experience companies have with AI is a bitter one. It is not a pleasant one. And, I started to thinking, why is that, right? The typical experience a company has with AI is they'll spend 1 to 2 years trying to hire a team because it takes time to find the right people. Everybody complains about how hard it is to find the right people. After 1 to 2 years of trying to hire a team, they spend the next 2 years finding out that they hired the wrong people, firing them, and then starting over. And that is it. That is literally the most common experience companies have with AI. It's not a good one. So why is that, right? I believe it is, given the requirements of what it means to be a great data scientist, right? I think a great data scientist is a person that is a statistician, mathematician, machine learning scientist, software engineer, good communicator, understands the business. It's a unicorn, right? And you can have unicorns, but you can't mass produce unicorns, right? If you think of the early days of aviation, you had the Wright brothers building the planes and then flying the planes. They were the pilots. It took a Wright brother to fly a plane. So how do you start United Airlines back then? Well, you'd have to train and hire 200,000 Wright brothers. You can't do that. You can't have 200,000 Wright brothers. I think this is the stage that AI is in today. It's the requirements are still too high. And while you can have some success stories with that, you're not going to be able to have every company in the world hiring people of the right talent. So that got me thinking, okay, what has to happen for that to change, right? What happened with aviation was that the field of aviation advanced so that the requirements for becoming a pilot were more reasonable, and then you can have many, many, many pilots, millions and millions of pilots. And I think that's the same thing that has to happen with AI, right? So if you look at the actual process of a data science project, what are the things that A, can be automated, and B, by automating them, you're reducing the requirements of knowledge for that person so that you can then have this scenario happening. And that concept is what got me started on thinking something like Opal had to exist, right? So that you could start to see this transformation of AI finally delivering on its promises.
That's something very interesting. And I like to, pinpoint on the analogy between AI industry and the aviation industry. So fundamentally, you're saying not everybody can be the builder of an airplane, the inventor of something new, and at the same time, the pilot. And we need to reduce the amount of skills necessary to pilot the airplane. Along that line, okay, so what are the pain points today in the process of deploying or building an AI product that you think or you're pursuing eliminating or making them simple? Can we let our audience understand what are the pain points in the places where more know-how is requested or more time goes into it to get done?
So there's going to be two very distinct groups of people, right? There's the problems from the companies that were able to hire the right talent, and then the problems of the companies that were not able to hire the right talent, right? And it's problems on both sides, but they're different kinds of problems. So let's start with the group of companies that are in the majority, which is they can't hire the right talent, or they don't have, or they haven't tried, right? For them, it's simple. It's whether they have no one, and so they're not really getting these projects going, or they have people, but they're just the wrong people, and they're not very good at just building models or using algorithms correctly, or knowing, how to process the data. Then the problem there is, because they don't have the right people, these projects take very long amount of time, and they end up with subpar results, right, or no results at all. So that's the type of problem that these companies see. Now, for the companies that actually have the correct talent, they still have problems. What are the problems there? One of them is the data scientists are usually not well embedded into the part of the business that's going to use the solution. So the main reason for that is that most companies create a central hub of data science or AI excellence, right? And then this AI team serves all the different groups within a company. And so that's why they're kind of detached from the business groups. And that's a problem. Usually there's two problems there that this creates. One is because of the barriers with communication, you end up with misaligned goals. And so a project that seems to be a success to a data scientist, for the other business group, it's a failure, right? So for a data scientist, he gets assigned something. Oh, you need to predict if a person is going to get in a car crash. He gets the data, he builds the model, and if he gets a model that's very accurate, he calls that a success, and he pushes it out to someone, and that's it. Well, that's not a success at all, right? If the company is not using that model, it doesn't matter that your model is accurate. Might as well be not accurate because nobody's using it. So there's this disconnect of what it means to be success versus not a success. The second problem is because there's this disconnect, the data scientists, everybody in their career, everybody in their lives needs to feel like they're succeeding or winning, right? And so the win for most data scientists is, can I get the most accurate model possible? That's what gives the data scientist pleasure and fulfillment of accomplishing their job. So what this creates is data scientists will spend months tuning a model, right? Fidgeting with the parameters. You know how addictive it is. Every data scientist listening to this knows. They say, oh yeah, I can get a model out in a week, but what was the last time you actually gave your boss or manager a model in a week, besides you trying the different algorithms, the different parameters, doing feature engineering. That's an addictive game because you keep playing with those things and then you keep getting better results. And that gives you that sense of fulfillment. The reason I'm mentioning this is that's the portion that is one of the portions that needs to be automated because it solves the problem for both the teams with the talent and the teams without, because this is the portion that teams without can't do. But once you automate that, then what is the purpose and what is the fulfillment of a data scientist? That's where that communication comes in. If you have a data scientist that's more engaged with the rest of the company, a data scientist that understands how the models that they build can affect the company, then their win, their fulfillment comes from seeing those models in fruition, seeing those models in production and affecting the company. Because the mind of the data scientist can be used in more valuable places than just choosing the learning rate and the number of layers in a neural network, right? The brain of the data scientist has creativity and problem solving skills. They need to be thinking about what other types of models can I build to improve my business. They need to be talking to people in the company and understanding what are the places that I can use AI to make my business better. These are places that will not be automated for decades because it requires very open-minded thinking, creative thinking. And that's where the job of the data scientist is absolutely secure. But their focus, their skills are going to be in different places, right?
So if we look at this area, so for the companies with right talent and the company without right talent, how your company now solves this problem and to what extent your company solves these problems?
Right. So if you think about the domain expert, right? A person that knows enough statistics and I guess some machine learning, but wouldn't call themselves a data scientist, but they understand their business really well. Now, rewind, 15 years, I can't remember exactly the year Kaggle came out, but rewind to the period before Kaggle. So before Kaggle, the domain expert was considered the best possible person to build a model because they understood the business, they understood the problem. And then Kaggle came along, right? And up to that point, they thought, there's no way a data scientist that doesn't know my field can build a model better than me. Kaggle comes along and says, well, here you go. You can put data sets from different industries and let pure data scientists work on it. And what people started seeing was that data scientists were consistently beating the domain experts, right? So then everyone flipped and said, oh, you know what? Domain expert is not necessary. A data scientist can beat a domain expert any day of the week. Kaggle has proven it, right? And I call this the Kaggle effect. This is the change in perception that Kaggle created, which is incorrect. Because the reason is, by the time a project gets put into Kaggle, the domain expert was the one understanding the business, formulating the problem, putting together the data set, and preparing it to match the problem that he formulated in his hypothesis. So by the time the data scientist at Kaggle gets the data, the domain expertise of the domain expert has already been imbued in the data and in the problem. So really what Kaggle proves is that if you have the perfect marriage, the perfect communication between domain expert and data scientist or machine learning engineer, you get a fantastic result. So with that in mind, right, we're trying to say, what if you could get that perfect communication within one person? Meaning, if you have software, like our software, right, that can automate the way a data scientist thinks, right, from feature engineering to the wrangling of the data, removing mislabeled data, looking at outliers, looking at anomalous values, looking at distributions and how to fix them if there's a problem, for scaling, normalizing, and other things like that. And then going into algorithm selection, tuning, hyperparameter optimization, the entire process all the way down to optimizing the model for production. If all that can be condensed into software and you can put that into the hands of a person that knows the domain, then you have that perfect marriage, right? And this can be put in the hands of a data scientist or in the hands of a domain expert, what they call citizen data scientists, right?
It's certainly very appealing business proposition to me, and I've been in this type of processes. So basically means that somebody like me doesn't need to spend 2 years rehashing all the Python and so on to get to the point to perform, and can just use whatever, let's say, business acumen he has to formulate the problem and get the results. But now what comes to my mind is, to what extent all of this is possible with Ople? Do we have some applications where this works better, some other areas where it works less? Can you maybe give us some example of problems that you can automate end to end?
Yeah, so one example was in a process of sanding down wafer chips, right, for computer chips. It's just a process of like sanding them down. The problem there is when they're sanding it down, there's a lot of different chemicals that they combine. And so they need to figure out what percentages of these chemicals. They also need to choose the pressure, the speed, the temperature. There's, a dozen or more parameters. And these are expensive experiments. So they can't just run every possible combination to see which one is the most efficient. So that's where machine learning comes in. The problem formulation is, what if we could build a model that could predict the efficiency of the sanding given the combinations of parameters, right? Typical input, output, very simple. This is a regression problem, not a classification problem, but still, right? So we had a customer onboarding where this was the problem they had, and they had a data set for it that was straight from the experiments they had run. So they didn't do anything to the data. They didn't, clean it or normalize it or anything. We were on a video call with them for 1 hour total. And within the first 20 minutes of the call, they used, logged into the software. We were just watching them use it so that we could answer questions if they had any. But they were to log into the software, upload their data, click a few times, name the project, kick it off, and within the first half of the call, the process was over, meaning the software said, hey, I'm done, which means you're skipping all those steps of feature engineering and then manipulation of the data and building a model and optimizing it and deploying to production. Within the call, all of that happened, and the person was able to test a model that was already deployed and say, wow, this is already more accurate than what took me weeks to build by hand. And it took me 25 minutes. So that's just an example, but this is the new way of thinking of these projects, right? These projects should be, the longest part should be thinking up ideas and formulating the problem. Once you have that, everything else should be extremely fast, right? And just done for you, period.
So do you think that a technology like this will also help to bring more people and bring more awareness with our companies about machine learning and the ways that it can produce business value?
Yeah, I think right now, like I said, people still have a pretty bitter taste in their mouths from AI. I think the return on investments aren't there. To be honest, I think for the first few years, I doubt that most companies were even looking for a return on investment. It was more of a, we need to invest in AI now so that in the future it'll pay back, but people weren't really looking for that return immediately. They were just saying, well, everybody else is doing AI, so I have to as well. If nothing else, for PR reasons. But that's turning now. Now the companies are going, okay, now show me the return. Now I care. And so when they start seeing the delivery, I think that's going to spread. If the field continues the way it is, then potential winter is inevitable, right? If there's only so many years that companies are going to keep pouring money into something without seeing a return on investment. But I think that we're still in time to make that transition to show companies that they can get a massive return and fast. And it's not rare to be able to hire people anymore that can do this. And they can see, look, you push a button, this model is done and in production and giving me real value. And then you can start thinking of what other projects can I do, right? You can really start to opening up the imagination to thinking, because right now most companies only have a few ideas of how they want to use AI. And the reason is not that most companies can't use AI in 1,000 different ways. It's that AI is so expensive and time consuming that everybody has these blinders on that, created by time and expense, and it prevents them from seeing the real possibilities. But once you remove these blinders and say, forget it, it's not time consuming and it's not expensive. It's easy, it's cheap, you can do it. You start to really get the creative powers going, right? If you look at, the airplane, we've been running with this example. It doesn't matter. The phone, the computer, the airplane, the car, even the telephone. When these technologies were still early and expensive and laborious, smart people in these industries didn't see the value, right? They said, a famous quote is, airplanes have no military value. The telephone is a fad. It's not any better or more useful than the telegraph, right? These are things that people thought. But then you start making it cheaper. You start making it easier. And then people start thinking, oh, what if we can, fly people across the world? Because now an airplane is not something that can just fly 100 meters, right? And it's also cheap and it can fly far. What if we could deliver packages with airplanes? What if we could, A, B, C, D, E? We haven't gotten to AI, to that with AI yet. We think we have. But we haven't. I really don't think we have, because it's still too expensive for us to really be imaginative with it.
To me, it's very interesting, and it connects to one topic that I'm really passionate about, and it's the following one. If we, move along the lines of this parallel with the phone and the invention of the phone, the fact that at the beginning it was difficult to use, expensive and so on, and then it's put it into millions of other applications, including jobs, the contact centers, telesales, for those who do it. What do you imagine that a technology like the one that your startup is bringing to the market, and, in general, technology of this type that improve the speed with which machine learning projects are implemented and make it easy, basically make it accessible to various other professional figures besides the data scientists? How do you think it will change the relationship between the different professionals involved? And if any, will it create a new type of jobs?
Yeah, so in the immediate future, it will absolutely create more data science jobs, because now the price is going to come down, the companies are going to see that it's more accessible, and companies that don't even have these openings because they know, even if they did, they couldn't hire these people, now they'll realize that they can. So and now you won't have to create this, central small AI hub that serves the entire company, because, you can't imagine hiring 1,000 data scientists. You can imagine hiring a dozen, but it will change so that now every division within every company can have a dozen data scientists. So companies that used to have a total of 20 to 50 data scientists could now have between 2,000 and 5,000 data scientists for a single company, because it's valuable everywhere in the business, and they can have people doing this job everywhere, up and down the business. So the immediate is that it's going to be more data science jobs, which is hilarious, because the common thought is that it's the opposite. Well, you're automating, of course you're going to take out my job if I'm a data scientist, but that couldn't be further from the truth. Then going forward, right, the cascading effect that you see of that is that once that happens, and now every division within every company and every industry has data scientists and starts actually seeing these models be put in production, right? I imagine that there's going to be jobs around the functioning of these models, because when you put these models into production, when a model gets used, something has to change in the company, otherwise the model is not useful, right? If a model is making predictions or showing some kind of insight and nothing changes in the company, then that's a useless model. But the fact that something's changing means somebody's doing something, right? It means somebody has to be taking action because of what this model is saying. And so, I can't name what these jobs exactly are going to be, but it seems that it's a logical conclusion to me that it will create more activities that will need to be done. What they are, I don't know, because I don't know what all these thousands of models are that companies can start to think about. We can start listing a few, but that's the point. There will be more things to do because they need to respond to what the models are doing. And so it's inevitable that there's going to be more jobs created there. as with any other technology that has come and gone, there's always first a fear that it's just going to be no jobs, and then eventually you see that, like you said, it turns around and people figure out, oh, it's just different jobs now, but more and higher level type jobs as far as cognitive skills.
When we do interviews like this, we like always to ask a question about who do you think is the right person to hire in a company like yours, and particularly around the machine learning, more of the core technology. Who is that person? What are the 1, 2, 3 qualities that you look in that person?
That's a very good question. I've in my career interviewed hundreds of people. We've had a lot of luck and interest at Opel. I mean, we're still a small company. We're just now approaching 30 people. We're almost 2 years old, but in these 2 years, we've had over 20,000 people apply directly to work at Opel. Direct applicants without recruiters. So we had to sift through a lot of resumes. And we hosted our own hiring events to just have people over and interview. I like to test people on things they don't know. So I'll introduce a topic that is pretty obscure within the machine learning realm and say, oh, blah, blah, blah. Do you know about this? And they'll feel eager to answer it if they know. And if they say they know it, then I drop it. I don't want to talk about it if they know it. If they say, no, I don't know, which by the way is 98% of the time, then I say, good. Since you don't know it, I'm going to ask you about it. And then basically I proceed to teach them the topic right there. I'll spend about 10, 15 minutes teaching them about a topic they've never heard of. And then engage them in, how do you make this better? I just explained to you an algorithm you never heard of. What do you see that's good and bad from it, and how do you improve on it? So I want to see that. I want to see somebody that is eager to learn new things and can quickly grasp a concept and start having ideas. And they don't have to be right ideas. They just have to be creative. They just have to show me that you can adapt like that. So that's one big thing that I really like in interviews. The second one is understanding something that you can explain to me without using any jargon or terminology, right? We'll talk about why is a random forest better than the decision tree, or about activation functions in neural networks. But I want to have that conversation so that a 9 or 10-year-old could be in that room and understanding what we're talking about. If you can show me that you can explain something to me at that level, it gives me confidence that you really know what you're talking about.
So very interesting. Now we know how people can cheat you in an interview. They have to come up with a lot of ideas.
Yeah.
or they might tell you that they don't know something that they actually know.
Yeah, I know. There's always gaming. Although that's not terribly hard to figure out when that's happening. I do enjoy playing poker, and I feel like I'm a pretty good read of people. So.
So very good. Let me ask you another, if you like, stupid question. But here is the thing. Now your company is 30 people, and you need to hire also marketing people. Soon you'll have a marketing team and also a sales team. And it comes the moment of they communicating what you're doing to the world. Now it happens that in the world of marketing, there are 3 words that are used very often in the same sentence, because most people don't know what they mean, and they use all of them so that they make sure that they're getting one right. And those words are artificial intelligence, machine learning, and deep learning. Now, if you had to hire a guy in marketing and you had to explain him how he's going to use those words and when he's going to use those words, what would you tell him?
Sure. And by the way, the question I told you, the complicated algorithm, I do that question for sales and marketing people as well. I do them for absolutely everyone. I don't care how technical or not technical you are. I want you to be able to understand something new and think with me about it. So that's a question I ask everyone, even though it's extremely technical. But we have a conversation that doesn't have to use the technical jargon. But now I'm going to answer your question. So I think it's pretty simple, right? I guess I could start from the top up or bottom top down or bottom up. But I think we can start with AI. I think AI is simple. It's basically anything that's artificial that mimics any form of intelligence, whether, I'm not talking about how narrow or wide. So an example is, my favorite example of AI is a paper towel dispenser in the bathroom, right? You put your hand under it, it detects your hand, it spits out a paper towel, right? You could be next to another human being and say, hey, can you please pass me a paper towel? And they're intelligent and they're gonna grab a paper towel and give it to you. If you ask that same question to a lobster or a snail, they're not gonna do that, right? They don't have that intelligence of understanding your request and then responding the appropriate way. So in a very narrow way, that is intelligence. That's mimicking the intelligence. It is mimicking the behavior of, if I ask you for something, you give it to me. And it's a very specific case, but that is artificial intelligence, right? And that's important because it separates it from machine learning. It's just anything. It can be simple, right? It can be simple, just a detector, and it just does one thing. It's not what people think of AI today, but it is. It is artificial, and it certainly mimics a pattern of intelligence. Of course, there's much broader ways of defining, but I think this is the all-encompassing one. When you understand that, then you go into machine learning. So machine learning is a series of algorithms that facilitate this prior rule-based system, right? So think about the paper towel example. It has a sensor, and all it does is, if you know code, it has an if statement. It says, if the sensor is triggered, spit out a paper towel, right? Now imagine that you wanted to make a more intelligent one, that based on the size of the hand, based on how wet, you wanted to dispense more or less paper towel, and if you sensed there was a foot, you didn't dispense paper towel, and if it was a child, you didn't, for security reasons, only adults can get paper towels. It can get pretty complicated, and now that if statement becomes something that is something, a human being cannot write anymore. Imagine, this if statement tree of ifs, and once it gets to like hundreds or thousands, it's pointless. That's where machine learning comes in. Machine learning is a family of algorithms that says, you know what? I don't know what these if-else's are, and I don't need to know. All I know is that I have these inputs, and these are the outputs that I expect. You go and figure out what the rules are. And then that's the job of the algorithm. And behind the scenes, a lot of these algorithms, they're not actually doing if-else. Doesn't matter. They're doing math. But that's what they're really learning. They're just learning how to map inputs to outputs without the human being having to specifically say, this is the rule set, right? And so you can see how machine learning is a series of techniques that allow you to achieve AI in a particular way. Deep learning is then under machine learning. It's simply one of those algorithms, right? Machine learning, there's random forest, there's logistic regression, there's nearest neighbor algorithms, and deep learning, which is based off of neural networks. So that's all that deep learning is. It's one method within a family of methods. And deep learning is rooted in deep neural networks. Neural networks are basically mathematical functions that take an input, perform math on it, pass it to the next layer that performs more math on it, pass it to the next layer that performs more math on it, and it does so many times until it finally spits out an answer. And the reason for all those layers of math is so that it can actually understand something complicated. If it was just one layer of math, it has smaller ability, not theoretically. Theoretically, actually, one layer is capable of mimicking any function. The problem is we can't train it to do so. But that's slightly more technical than the crowd that you're asking this question for.
So this is a very exhaustive answer, if you like. It's one of the most exhaustive I have seen. As our time, goes towards the end, I'd like to ask you one last thing, and it is basically, let's look at the future a little bit more than we did before. 3 to 5 years from now, where do you see a software like the one developed by Ople going? What do you think is going to be possible 3 or 5 years from now that it's not possible today? And what do you think will be the net benefit 3 or 5 years from now for the end users that we do not yet have it accessible today?
I think that there's two avenues of answering that question. One is from a product business standpoint. One is from a technical standpoint. From a product business standpoint, right? I think companies have three kinds of problems when it comes to AI. They have difficult, impossible, and unimaginable. So difficult problem is, you have data scientists, and any problem they're working on is difficult simply because it's hard to find the people to do it, and it takes a lot of time to do it. That's difficult, right? Even though technically speaking for the data scientist it's easy, but from the company's perspective, that's difficult. Most companies cannot even solve those problems yet because they don't have the right people to do it. But a lot of companies are starting to solve the difficult problems. Then you go into the impossible problems, which are, I've talked to plenty of companies that said, yeah, we have people that can do some machine learning, but we have tons of problems that would require computer vision and deep learning. And they said, because of where we're located in the country and what we do, we know that we can't attract that type of talent. So we're not even planning to ever solve these problems of deep learning computer vision. That's in the impossible category. And there's probably an order of magnitude more impossible ones than difficult ones. And then you go to the unimaginable ones, which is the ones that, as I mentioned before, companies aren't even thinking of yet because they're blinded and their imagination is being constrained. So 3 to 5 years from now, from a business perspective, I think hopefully as close to 100% of companies as possible are already solving the difficult problems and tackling the impossible ones because they're not going to be impossible anymore. So I think that's the 3 to 5 year range. Beyond the 5 year range, which is really what I'm excited about, is seeing what these unimaginable problems are. Once people start racking off and crossing off their list of difficult and impossible, they'll start imagining and thinking of what's some really cool stuff that they can do with AI and machine learning. From a technical perspective, I think what we're really doing is mimicking the thought process of a data scientist, right? It's not just that we're tuning parameters. It's a much higher level than that, right? Well, we call it learning to learn, but it's evolving as if a data scientist was evolving. Meaning, when I worked on my first project, I took a certain amount of time to get to a really good model that I felt comfortable with. As I grew as a data scientist, as I became better, I got easier for me to get there and it took less time, right? So I was getting better at that process. The same thing with, if you look at Gilberto, right? One of the best cavaliers in the world has won, I think, 38 gold medals, and he works with us. He's at Ople. He also became very good at that. He can enter any kind of competition and win more often than anybody else has ever won on camera, right? So what is it that he learned? What is the cost function in his brain that allowed him to become a better data scientist, right? We have him here because we're modeling that. We're actually modeling what information is the brain processing and what is the brain solving that allows it to become a better data scientist, right? And once you have that, and once you have enough users using the product, then you basically end up with a data scientist in the software that has seen more projects than any human being will ever be able to see. Because you could have thousands and thousands of copies of the software working on this with users. And so the answer is, I'm excited to see what it'll be able to do. Because the way we're opening up the possibilities of what we allow the software to do, it goes from simple to complex. And simple is just doing what we do today, but better, right? But then we have ideas on the roadmap and things that we started to play with. Of what if we allow it to do things that we don't know what they are yet? What if we open the doors to letting it create things in that data science project that we don't know? So I think that's in the 5 years and beyond stage of the technology that we have. And I think that's pretty exciting.
Definitely exciting, and definitely something that I think it requires a focus of its own. I would have to ask like a million questions, but if you see it, it kind of falls within this concept of bringing more cognitive capabilities to the machine, basically, and mimicking the human behavior. In this case, it's understanding the human behavior and then extrapolating it to problems of different nature. So it's pretty interesting. Our time came to an end, but this was a very interesting discussion. I wanted to thank you for your time. And for our audience, please comment below if you have questions. We're more than happy to answer. And if you have suggestions about other topics to cover, please let me know either by email or by commenting on the video here. Pedro, once more, thank you so much for being here.
Thank you so much. This was fun.